What happens when you take a 70-horsepower Flathead 6 and make it run faster than V8s with twice the power? In 1950, Studebaker answered that question with one of the most unlikely performance cars ever built. The Champion could hit 100 miles per hour. Let that sink in. 70 horsepower, 100 miles per hour. This is the story of how Studebaker broke the rules of physics and created a budget car that embarrassed the big three. Picture this. It's 1950, and you pull up to a stoplight in your brand new Studebaker Champion. Next to you, a guy in a Mercury with a 2i55 cubic inch V8 smirks at your little six-cylinder. The light turns green. He floors it, expecting to leave you in the dust. But something strange happens. Your Champion keeps up. And on the highway? You're pulling away from him at speeds he didn't think were possible. His V8 makes a 110 horsepower. You've got 70. But you're disappearing into the distance at over 100 miles per hour. The 1950 Studebaker Champion wasn't supposed to be fast. It was supposed to be cheap. But what Studebaker created was a physics lesson on wheels that would reshape how Detroit thought about performance. This wasn't about brute force. This was about outsmarting the air itself. To understand how revolutionary the Champion was, we need to understand what normal looked like in 1950. The automotive world was simple. Want to go fast? Get a bigger engine. More cubic inches meant more power, meant more speed. It was gospel. Ford's new for 1949 Flathead V8 displaced 239 cubic inches and made 100 horsepower. Chevrolet's inline 6 displaced 216 cubes and produced 92 horses. Plymouth's Flathead 6 managed 97 horsepower from 217 cubic inches. These were the economy engines, and they delivered economy performance. A typical family sedan weighed between 3,200 and 3,500 pounds. Top speeds rarely exceeded 85 miles per hour for six-cylinder cars. 0 to 60 took 20 seconds or more. Fuel economy hovered around 18 miles per gallon. Aerodynamics? Nobody talked about aerodynamics. Cars were styled to look powerful, not slip through air. Chrome was king. Hood ornaments stood tall and proud. Grills got bigger every year. Wind resistance was something airplane engineers worried about, not car designers. But Studebaker was in trouble. As the smallest of the independent manufacturers, they couldn't compete with the big three on their terms. They didn't have the resources for massive V8 development programs. They couldn't afford to tooling for bigger, heavier cars. They needed something different, something that would make buyers take notice without breaking the bank. Enter Raymond Loewy, the French-born industrial designer who'd already revolutionized everything from locomotives to Coca-Cola bottles. Studebaker gave him a challenge. Make our economy car special, make it memorable, make it profitable. Loewy looked at what everyone else was doing and went the opposite direction. While Ford, Chevy, and Plymouth were making their cars look like chrome-laden battleships, Loewy drew something that looked like it came from outer space. The front end came to a point. Not a flat grille with a hood ornament, but an actual point, like a bullet or a jet fighter. The spinner in the center looked like a propeller hub. The hood sloped down dramatically. The windshield was raked back at an aggressive angle. The roofline flowed smoothly into the rear deck. Every surface was curved to guide air around the car, not through it. The engineering team was skeptical. Bob Burke, Loewy's right-hand man, had to fight for every aerodynamic detail. The production engineers complained about the complex curves. The stamping dies would cost a fortune. The assembly line would need to be reconfigured. The bean counters ran the numbers and shook their heads. But Loewy and Burke persisted. They knew something the spreadsheet jockeys didn't. They understood that air resistance increased with the square of velocity. Cut the drag coefficient in half, and you could go dramatically faster with the same power. Make the car lighter, and you'd need even less power to accelerate. Combine both approaches, and you could create something extraordinary. The Champion's body was a masterpiece of efficiency. That pointed nose wasn't just styling, it was functional. Air hitting the front of the car was immediately directed around the sides. No flat surfaces to create pressure buildup. The spinner in the center actually helped by creating a small vortex that smoothed airflow. The sloped hood reduced the frontal area. Less car pushing through the air meant less resistance. The windshield angle was calculated to minimize turbulence. Too vertical and you'd create drag. Too raked and you'd get lift. Loewy's team found the sweet spot. The roofline was pure aerodynamic function. No unnecessary height. No squared-off rear window. Just a smooth curve from windshield to trunk. The rear end tapered gradually, no abrupt cutoff to create turbulent wake. The air released cleanly, reducing the vacuum effect that pulls cars backward. When they tested the clay model in Studebaker's makeshift wind tunnel, really just a big fan and some smoke streams, the results were staggering. The drag coefficient came in at 0.42. For context, most 1950 cars were between 0.55 and 0.70. A modern Toyota Camry is about 0.28. The Champion was decades ahead of its time, but aerodynamics alone wouldn't make the Champion special. The car needed to be light, really light. Studebaker's engineers turned to unibody construction, welding the body and frame together as a single unit. This wasn't entirely new. Nash had been doing it since 1941, but Studebaker refined it to an art form. Every panel was structural. Every piece served multiple purposes. The result was a car that weighed just 2,535 pounds. A comparable Ford weighed 3,015 pounds. A Chevrolet tipped the scales at 3,095. Plymouth came in at 3,025. The Champion was 500 pounds. Lighter than its rivals. That's like leaving 7 passengers behind. Under that swoopy hood sat Studebaker's 169.6 cubic inch L-head inline 6. On paper, it was nothing special. Bore and stroke measured 3 inches by 4 inches exactly. Compression ratio was a modest 7.01, typical for regular gasoline. The L-head design, what we call flathead, put the valves beside the pistons in the block, not overhead. This limited breathing and RPM potential. Maximum power came at just 4,000 RPM. Peak torque of 138 pound-feet arrived at 2,000 RPM. The single-barrel Carter carburetor was tiny, with a venturi just over an inch in diameter. The intake manifold was cast iron, heat from the exhaust warming the incoming charge. The camshaft was conservative, with mild timing and minimal overlap. The exhaust system was a simple single pipe with one muffler. Studebaker's engineers knew they couldn't match Detroit's power numbers, so they didn't try. Instead, they optimized everything for efficiency. The combustion chambers were carefully shaped to promote complete burning. The pistons were lighter than standard, reducing reciprocating mass. The connecting rods were shot-peened for strength without adding weight. The crankshaft was balanced to tighter tolerances than normal production standards. The flywheel was lightened by several pounds. Less rotating mass meant quicker acceleration. The 3-speed manual transmission had perfectly spaced ratios. First gear was low enough for strong starts. Second covered the crucial 30-60 MPH range. Third was tall enough for relaxed cruising. The synchronizers on second and third were robust and smooth. The rear axle ratio was the key to the Champion's speed secret. While competitors used 4-10-1 or 4-2-7-1 gears for acceleration, Studebaker fitted 3.7-3.1 cogs. This meant the engine turned fewer RPMs at any given speed. Less friction, less pumping loss, more efficiency. Here's where it gets interesting. Motor Trend magazine got their hands on a Champion in late 1950. Their test driver, Walt Warren, couldn't believe the speedometer. He tried again and again. The little Studebaker hit 102 miles per hour. They published the results, and readers thought it was a typo. How could 70 horsepower push a car to 100 mph? Warren explained it in their next issue. The Champion's aerodynamics reduced power requirement at high speed by nearly 40% compared to conventional designs. The lightweight meant less rolling resistance from the tires. The tall gearing let the engine run at its power peak at top speed. The combination was multiplicative, not additive. Each advantage amplified the others. But wait, there's more. The Champion didn't just go fast. It sipped fuel like a miser. Highway fuel economy ranged from 25 to 30 miles per gallon. Some owners reported even better with careful driving. A Ford V8 struggled to break 20 mpg. Chevrolet and Plymouth 6s rarely exceeded 22. The Champion delivered V8 performance with four-cylinder. Economy. Studebaker's advertising department had a field day. The car that's really new, they proclaimed. First by far with a post-war car. The bullet nose became the talking point at every dealership. The engineering community was fascinated. Society of Automotive Engineers meetings featured lengthy discussions about the Champion's design. Was aerodynamics really that important? Should Detroit be paying more attention to drag coefficients? The Big Three sent engineers to buy Champions for analysis. They put them in wind tunnels. They dissected the engines. They weighed every component. The reports were unanimous. Studebaker had found a different path to performance. The bullet nose design was polarizing. Some loved it. They said it looked like the future, like a rocket ship ready for takeoff. Others hated it. They called it the pickle, or worse. But everyone talked about it. You couldn't ignore a Champion on the road. That spinning propeller nose was instantly recognizable from a quarter-mile away. Studebaker's dealers reported something interesting. Customers who came to mock stayed to buy. Once they drove the Champion, felt its surprising acceleration, experienced its stability at speed, they were converted. The test drive became Studebaker's secret weapon. Production ramped up quickly. The 1950 model year saw 270,604 Champions roll off the line. For context, Studebaker's total 1949 production for all models was 228,000 units. The Champion alone outsold most entire brands. The Starlight Coupe was the star. With its wraparound rear window, another Loewy innovation, it looked like nothing else on the road. The four-door sedan appealed to families who wanted economy without sacrifice. The two-door sedan attracted younger buyers on tight budgets. The convertible, though rare, was a statement piece. Racing wasn't Studebaker's thing, but privateers took Champions to the Bonneville salt flats. In the under 170 cubic inch class, they dominated. One Champion with nothing but safety equipment added hit 108 cuartos. Another, with mild engine modifications, reached 115. These weren't purpose-built race cars. They were essentially stock vehicles proving that aerodynamics mattered more than anyone had realized. The competition scrambled to respond. Ford rushed their new overhead valve six-cylinder into production for 1952. Chevrolet completely redesigned their cars for 1953 with sleeker bodies. Plymouth finally abandoned the Flathead 6 in 1955. But they all missed the point. They made their cars lower and wider, adding weight. They focused on style over function. Chrome grew like cancer. Tail fins sprouted. The lessons of the Champion were forgotten in the horsepower race of the mid-1950s. Studebaker's engineers weren't done innovating. They experimented with supercharging the Champion engine. Early tests showed 95 horsepower was achievable without major modifications. They developed an overdrive unit that dropped cruising RPM even further. Fuel economy approached 35 mpg in testing. They designed a lightweight automatic transmission specifically for the Champion. It weighed 40 pounds less than competitive units. But Studebaker's financial situation was deteriorating. The Korean War brought material shortages and price controls. Labor disputes shut down production repeatedly. The company couldn't afford to develop and produce these innovations. The 1951 Champion received minor updates. The nose was redesigned with a more conventional appearance. Some say this was a mistake. The drag coefficient increased to 0.46. Top speed dropped to 95 mph. Sales remained strong. 246,000 units, but the magic was fading. By 1952, the Big Three had caught up. Ford's new overhead valve 6 made 101 horsepower. Chevrolet's revised styling was modern and appealing. Plymouth's reliability was finally improving. The Champion was still efficient, still clever, but no longer revolutionary. Raymond Loewy fought for another radical design. His 1953 Starliner Coupe was gorgeous, with perfect proportions and clean lines. But it was expensive to build. Studebaker needed volume, not style awards. The company's merger with Packard in 1954 was supposed to save both brands. Instead, it hastened their decline. Resources were spread too thin. Quality suffered. Dealers defected to other brands. The Champion soldiered on through 1958, but it was a shadow of its former self. The original's lightweight efficiency was compromised by added size and weight. The clever engineering was buried under cost-cutting measures. The final Champions were forgettable economy cars in a market that had moved on to bigger, faster, more powerful machines. But here's the thing about the 1950 Champion. It proved something important. It showed that there was another way to think about performance. You didn't need massive displacement. You didn't need hundreds of horsepower. You needed to understand the problem you were trying to solve. Studebaker's engineers understood that moving through air was the real challenge at high speed. They understood that weight was the enemy of acceleration and efficiency. They understood that optimization beats brute force. Modern automotive engineering has vindicated the Champion's approach. Today's cars use wind tunnels and computational fluid dynamics to minimize drag. Lightweight materials like aluminum and carbon fiber reduce mass. Small turbocharged engines deliver power efficiently. The 2024 Toyota Prius, with its 0.27 drag coefficient and 2,050-pound weight, is the spiritual successor to the Champion. It's not about the specifications, it's about the philosophy. So, what was actually going wrong in Detroit while Studebaker was building the Champion? The Big Three were trapped in their own success. They had massive factories tooled for big cars. They had V8 production lines that needed to run. They had customers conditioned to expect more size, more chrome, more everything. Innovation meant adding power, not reducing resistance. Progress meant bigger engines, not better aerodynamics. Efficiency was for imports and oddballs. The Champion's engine deserves more credit than it gets. That little 170 cubic inch 6 was a masterpiece of simplicity. The Flathead design was ancient. Side valves had been around since the beginning of internal combustion. But Studebaker's execution was flawless. The block was cast with unusual precision for the era. Core shift, when the sand cores moved during casting, was minimal. This meant consistent cylinder wall thickness and better cooling. The head was a single iron casting with integral intake manifold. Fewer joints meant fewer places for leaks. The combustion chambers were carefully shaped. Ricardo's research on turbulent head design influenced the layout. The valves were shrouded to create swirl. The spark plugs were positioned for optimal flame propagation. This attention to detail extracted every possible horsepower from the limited breathing of the L-head design. The cooling system was overbuilt. The radiator had 20% more capacity than calculations required. The water pump moved 35 gallons per minute at peak RPM. The fan was positioned for maximum airflow through the core. Why did this matter? Because an engine running at optimal temperature makes more power and lasts longer. The Champion could maintain a 180-degree coolant temperature even at sustained high speed. Competitors often overheated during extended full-throttle runs. The lubrication system was equally robust. The oil pump was gear-driven off the camshaft, ensuring positive pressure at all speeds. Oil capacity was 5 quarts, generous for a small 6. The filter was full flow, unusual for economy cars. Oil passages were drilled, not cast, for smooth flow. The main bearings were massive, for the engine size. All this meant the Champion's engine could run at wide-open throttle indefinitely. Try that with a Ford Flathead. The electrical system was 6-volt, standard for the era, but Studebaker used heavier gauge wiring than normal. The generator was oversized at 30 amps. The battery was positioned for optimal weight distribution. The starter motor was a reduction gear type for reliable cold starts. These details mattered. The Champion started easier, charged faster, and had fewer electrical problems than its rivals. Now let's talk about that transmission. The 3-speed manual was called the Studebaker Synchromesh, and it was special. The synchronizers used a cone-type design instead of the common dog type. This meant smoother, faster shifts. The gear ratios were perfectly spaced. First gear was 2.67.1, second was 1.551, third was direct drive 1.1. With the 3.731 rear axle, this gave overall ratios of 9.95, 578, and 373. The spread was ideal for the engine's narrow power band. You could accelerate smoothly from walking pace to 100 mph without lugging or over-revving. The clutch was a 9-inch single dry plate design. Nothing fancy, but properly sized for the torque. The pressure plate was made by Borg and Beck, the best in the business. The throwout bearing was permanently lubricated. The linkage was mechanical, not hydraulic for better feel. Engagement was smooth and predictable. You could slip the clutch for slow-speed maneuvering without burning it up. The suspension deserves recognition, too. The front used independent coil springs with unequal length A-arms. This was advanced for 1950. Most competitors still used solid axles. The geometry was designed for minimal camber change through the travel. This kept the tires planted during cornering. The anti-roll bar was standard equipment, unusual for economy cars. It reduced body lean without harming ride quality. The rear suspension was conventional, solid axle with leaf springs. But the springs were longer than typical, 48 inches versus the common 42. Longer springs meant better ride quality and less axle hop under acceleration. The steering was cam and lever type, not the more expensive recirculating ball. But Studebaker's execution was excellent. The ratio was 20.1, slow by modern standards, but quick for 1950. The turning circle was just 37 feet, remarkable for a 113-inch wheelbase car. The steering wheel was 18 inches in diameter for good leverage. Power steering wasn't needed. The Champion was light enough and balanced enough that parking was easy. The brakes were hydraulic drums all around. The front drums were 11 inches, the rears 9 inches. Total swept area was 156 square inches. For a 2,500-pound car capable of 100 mph, this was marginal. But Studebaker used finned drums for better cooling. The brake fluid reservoir was mounted high for better vapor lock resistance. The pedal ratio was optimized for good feel without excessive effort. Panic stops from high speed were harrowing, but normal driving was fine. Tires were 6.40x15 bias ply, standard for the class. But Studebaker recommended 28 psi front and 26 psi rear, higher than the common 24 psi all around. Higher pressure meant less rolling resistance and better fuel economy. It also improved high-speed stability. The spare was full size, mounted in a well in the trunk floor. The jack and tools were secured in a separate compartment. Everything had its place. The interior was Spartan but functional. The seats were flat benches, front and rear. Upholstery was typically cloth, though vinyl was optional. The dashboard was painted metal with minimal bright work. Instruments included speedometer, fuel gauge, temperature gauge, and ammeter. No tachometer, no oil pressure gauge. The heater was optional, as was the radio. The windshield wipers were vacuum-operated, which meant they slowed down under acceleration. The turn signals were not self-canceling. You had to remember to turn them off. The horn ring was full circle, easy to find in an emergency. But the Champion's real innovation was invisible. It was the philosophy behind it. While Detroit was adding weight and complexity, Studebaker was subtracting. While others were making cars bigger, Studebaker made them better. The champion asked a simple question: what if we optimized everything for efficiency instead of excess? The answer shocked everyone. A 70-horsepower economy car that could run with V8s, a family sedan that got 30 miles per gallon, a $1,500 automobile that embarrassed cars costing twice as much. The champion didn't just compete, it redefined the competition. Let me put that in perspective. A 1950 Ford Custom with the Flathead V8 cost $1,645. It weighed 3,310 pounds and topped out around 90 mph. Fuel economy was 18 mpg on a good day. A 1950 Chevrolet Styleline with the Blue Flame 6 cost $1,529. It weighed 3,095 pounds and struggled to reach 85 mph. It might get 20 mph with careful driving. The champion cost $519. It weighed 2,535 pounds. It could hit 100 Nm. It delivered 25 to 30 miles regularly. Which would you choose? The market chose the champion. In 1950, Studebaker outsold Plymouth. Think about that. Plymouth was part of Chrysler Corporation with massive resources and a huge dealer network. Studebaker was an independent with a fraction of the budget. But they sold more cars, not through marketing, not through dealer incentives, through engineering. The champion's influence extended beyond sales numbers. It forced Detroit to think differently. Ford's response was the 1952 mainline with the new overhead valve 6. It made 101 horsepower but weighed 3,190 pounds. Fuel economy improved to 22 mpg. Progress, but not revolution. Chevrolet introduced the Blue Flame 140 in 1954. More power, but also more weight. The efficiency gains were minimal. Plymouth kept refining the Flathead 6 until 1955. They never caught the champion's combination of speed and economy. But the real impact was philosophical. The champion proved that innovation didn't require massive investment. It showed that clever engineering could beat brute force. It demonstrated that efficiency and performance weren't mutually exclusive. These lessons would be forgotten in the horsepower wars of the 1960s, only to be rediscovered during the fuel crises of the 1970s. Today, we take aerodynamics for granted. Every new car spends hundreds of hours in wind tunnels. Computational fluid dynamics guides every surface. Drag coefficients below 0.30 are common. Active aerodynamics adjusts to driving conditions. But in 1950, Studebaker was alone in this pursuit. They saw what others missed. They understood what others ignored. The lightweighting philosophy is equally relevant today. Modern cars use aluminum space frames, carbon fiber panels, and magnesium components to reduce mass. The 2024 Mazda MX-5 Miata weighs 200 to 341 pounds and delivers sports car performance from 181 horsepower. Sound familiar? It's the champion formula. Less weight needs less power, needs less fuel. The tragedy is that Studebaker couldn't capitalize on their innovation. Financial troubles, labor disputes, and poor management decisions doomed the company. The last Studebaker rolled off the line in 1966, built in Canada from leftover parts. The company that pioneered aerodynamic efficiency died just as the world was beginning to understand its importance. But the champion's legacy lives on in unexpected places. Gordon Murray, designer of the McLaren F1, cites early aerodynamic cars as inspiration. Colin Chapman's add lightness philosophy at Lotus echoes Studebaker's approach. Modern efficiency champions like the Toyota Prius and Tesla Model 3 use the same principles: reduce drag, reduce weight, optimize everything. The surviving champions are treasured today. Collectors appreciate their unique style and engineering philosophy. The Studebaker National Museum in South Bend, Indiana, displays several pristine examples. The bullet nose design that once polarized opinion is now considered art. Classic car shows feature special classes for Studebakers. The Champion, once mocked as the Pickle, is now recognized as a milestone in automotive design. Restoration parts are surprisingly available. The Studebaker Drivers Club maintains supplier lists and technical archives. Original engines are rebuilt to factory specifications, or better. Modern radial tires transform the handling. Electronic ignition improves reliability. Some owners fit overdrive transmissions for even better fuel economy. The Champion remains practical transportation 74 years later. But the real measure of the Champion's success isn't in museums or car shows. It's in the fundamental question it posed. What if we designed cars intelligently instead of incrementally? What if efficiency was the goal, not just a byproduct? What if less really could be more? Studebaker answered those questions in 1950. They took a 70-horsepower Flathead 6 and made it run 102 miles per hour. They achieved V8 performance with 4-cylinder fuel economy. They proved that smart engineering beats dumb power every time. The Champion wasn't just a car, it was a statement. It said that innovation doesn't come from doing the same thing bigger. It comes from doing something different better. So the next time you see a modern car with its sleek aerodynamics and lightweight construction, remember the 1950 Studebaker Champion. Remember the bullet nose that sliced through the air. Remember the engineers who chose efficiency over excess. Remember the little 6-cylinder that could. Because sometimes the most revolutionary ideas come from the most unlikely places. Sometimes David really does beat Goliath. And sometimes 70 horsepower is all you need. What's the most unlikely performance car you've ever encountered? Let me know in the comments below. If you enjoyed this deep dive into automotive history, make sure to subscribe. We're just getting started exploring the engineering marvels that change the world. Until next time, keep those engines running, no matter how small they might be.